Hello and welcome to the flipped recording for 2.07 Periodic Table and Elements. As we get started today, just a couple of reminders for you. Don't forget that you will be submitting your science notebook at the end of the unit, so you do need to take notes for this lesson as well as answer those guiding questions. And we will work on doing that together. And then if you're struggling with taking notes, if you just listen for the parts of the lesson that I tell you to write down, you will get plenty of information. And I'll also be covering those guiding questions, so be sure to jot down those answers as well. So now jumping into the lesson, we are going to take a look at understanding the periodic table and elements. So here's the lesson introduction, page 1. For hundreds of years, scientists have been observing properties of materials. They observed patterns in the way materials broke down or combined with other materials. Materials that cannot be broken down further are called elements. You definitely want that definition in your notes. Scientists observed that all materials were made of basic particles called atoms. They also proposed that all atoms of an element are the same. Scientists try to classify elements in groups with similar properties. They hoped that understanding the pattern of these groups would lead to a deeper understanding of the nature of matter. So here are our lesson goals, and there is your keyword to include in your notes as well. And then here are the guiding questions that we're going to be taking a look at. I'm going to take a quick screenshot and put those over to the side so I can refer to those as we go along. And so we're ready to go jump into the lesson. So discovering elements. And on the guiding questions, the first question or the first answer we're looking for goes to question 1. It says most elements can only be made where? So we will find that somewhere in our reading. In ancient times, the only elements that could be found or made in their pure form were carbon, gold, silver, iron, mercury, tin, lead, sulfur, and copper. There were about 100 more elements still to be discovered. This was because most elements can only be made pure in well-equipped chemical laboratories. So that is your answer to guiding question number 1. Most elements can only be made pure, meaning gold is all gold and nothing else mixed in well-equipped chemical laboratories. So for example, the magnified salt crystal shown here is a combination of the elements sodium and chlorine. It takes special conditions and a lot of energy to break this salt down into its elements. So as the list of known elements increased in the 1800s, scientists continued to look for a pattern in the properties of elements. Several scientists tried to arrange elements in a logical way. So the next question, guiding question that we're looking for is, what is the periodic law? So scientists arranged the periodic table in a logical way that grouped elements based on similar properties. So that is probably noteworthy as well. So here's the periodic table of vehicles. Notice how the vehicles are organized by number of wheels. Make your own table by arranging the vehicles based on their properties. So if we take a look at the picture here, you can see that in this group you have 2 wheels, this group has 3, and this group has 4. So they're just grouped together by similarities. So what are some other ways you could organize the vehicles? Maybe by color. Maybe by 4, 3, and 2 in different colors. So lots of different ways they're organized by the number of stripes. So how is the periodic table of vehicles similar to the periodic table of elements? The vehicles are arranged in a logical way based on their properties, similar to the way the elements are arranged based on their properties. So developing the periodic table, early chemists didn't know much about atoms, but they were able to arrange elements in order of increasing atomic mass. When they did this, they saw that properties of elements repeated at regular intervals or periods. This characteristic of repeating properties is called periodic law. So make sure you get that definition down. And you may want to also put a bullet point that says they arrange elements in order of increasing atomic mass. Scientists wanted to illustrate periodic law by arranging elements in a table called the periodic table. Several scientists designed periodic tables, but a Russian chemist named Dmitry Mendeleev was the first to get it essentially right. Mendeleev's table looks much like the one used today. So what is periodic law? Remember, you want to have that in your notes. It's the characteristic of repeating properties as shown on the periodic table, and that is called periodic law. And then how was the periodic table originally organized? So they were originally organized in the order of increasing atomic mass. All right, so moving on. Number 3, the next guiding question that we're looking for says, how was the periodic table proposed by Moseley different from the one proposed by Mendeleev? So we'll be looking for that answer. So it was quite a feat for Mendeleev to devise his periodic table based on the properties of the known elements. Look closely at Mendeleev's periodic table. You will see something amazing. He left blank spaces for elements he believed would be discovered in the future, and he was right. This is a classic example of verifying a scientific theory by using it to make correct predictions. So why did Mendeleev leave blank spaces? And that is because he knew that there were elements that were undiscovered. So this is kind of a rough sketch of what the very first periodic table looked like as he developed it. So Mendeleev's table listed the elements by arranging them in order of increasing atomic mass. In the early 1900s, Henry Moseley, a British physicist, devised a new technique of determining the number of protons in each atom and called its atomic number. He determined the unknown atomic numbers of many elements and rearranged the periodic table in order of atomic number. His results led to more predictions of new elements that were later found. So how is this table different than the one proposed by Mendeleev? So that's guiding question number 3. And we saw that he organized the table by increasing atomic number, and the one proposed by Mendeleev was increasing atomic mass. So if you're thinking, what does that really even mean? If you look at an element on the periodic table, the atomic number is the number at the top, like 1, 2, 3, 4, 5. And that's the number of protons that are in that element. Mendeleev put them in order of atomic mass, which is the decimal number below the element symbol. So that is the difference in those two things. And the next question that we're looking to answer, guiding question 4, is how is the modern periodic table structured? So the modern periodic table, it says check out the modern periodic table on the next screen. When you look at an element's square on the table, you'll see at the top the number is the atomic number. That equals the number of protons and also the electrons. Those will always be equal. And then atom of that element. And then the bottom number is the atomic mass, which measures the mass of the atom and is very close to the sum of the number of protons plus the number of neutrons. So protons plus neutrons equals, is that what it is? The atomic mass is very close to the sum of protons and neutrons. So you might want to write that out. Protons plus neutrons equals the atomic mass. And then notice that some of the elements have chemical symbols printed in black, while others have symbols in different colors. And here's what they mean. So this would be helpful to write into your notes, is that elements in black are solid at room temperature. If they're blue, they're liquid at room temperature. If they're red, that means they're a gas at room temperature. And elements with symbols in green are not found in nature. That means they're only created in a laboratory. So this would be an okay thing to copy and paste into your notes. And if you look at this periodic table, it's really tiny. So it's really hard to get the information that you would need in order to do really anything with it. So I recommend printing yourself a periodic table that looks very similar to this at the website ptable.com. And that's a really cool website. You may want to bookmark it. It allows you to look at different versions, like different ways that elements can be arranged, or features, properties that you might want to be looking at. So it's a really cool website, and I would go ahead and print yourself a periodic table to have as you work through units 2 and 3. The other thing you may want to do is take an element as a model, draw it in your notes, and then go back and label. Remember when they explained all of this, that the atomic number at the top. So let's say, for instance, you took hydrogen. It has a 1 at the top. You could point to that 1 and write is equal to the atomic number. It's also equal to the number of protons and electrons. And then you might write 1.01 under the H, because that's its atomic mass. And we talked about that being the sum of the protons and neutrons. So you may want to write that out, kind of drawing that element so that you're able to remember what those things mean. So the structure of the periodic table, when you look at it again on the next screen, you're going to check out the arrangement of rows and columns. So the horizontal rows, horizontal means going across like the horizon, that's called a period. And the way I remember that is there's a period at the end of a sentence. And so you may want to write that in your notes as well, because you'll be asked to identify elements in a certain period or a certain group. So each element in a period has one more outer electron than the element before it, and that's noteworthy as well. The outermost electron in an element's atoms control the properties of that element. So the outermost shell, remember we talked about them being stacked in those shells. And so the increase in the number of outermost electrons across the row causes properties to change as it goes across the row. So the vertical columns are called groups or families. So there are 18 of those. You may want to write that in your notes as well. All the elements in a group have the same number of outer shell electrons. So that means they have similar properties. They're either highly reactive or they're not. So there's a lot of different things that make those things in the family the same. Kind of like your family. You're not identical, but you have a lot of the same characteristics compared to maybe your neighbor. So the families have similar characteristics in their vertical columns. So here's that example again. We're talking about groups or families. These are all highly reactive metals. And then you've got the period, right, which goes horizontally. And then the color coding is also very important to note. So you can go through and work through any of the questions that you miss here. You may want to include in your notes. You'll likely see that on a quiz or a test at the end of the unit. So if you missed one, I would make sure you get the correct answer and include that in your notes as well. So here are some things to review. It says the periodic table is quite an impressive collection of elements. It contains many scientists' observations and discoveries. The history behind the arrangement of the elements is also quite impressive. So you've got that table again. It lets you go through and click on some different things, just looking at different things. But like I said, it's so small. Use the ptable.com. It's much better. And then as you wrap up, this is an activity kind of letting you work through looking at different elements, and you're able to move these and kind of match them. So it's just practice using the atomic number, understanding what it is, using the periodic table. So if you can do this activity, then you really have a good understanding of how it's set up. And that takes us to the end of the lesson. So going back, I hope you've taken good notes. This is a lot of information to take in. It was kind of a long lesson. and you will use this information throughout the unit. So next, just look for the Float follow-up session coming up. Come see me in Help Lab if you have any questions, and have a great day.